Question 4.21 from the homework is a pretty challenging question because it's a percent yield calculation. And percent yield, just to remind us, is our actual. So you went to lab, did the experiment, collected the product, and measured it out at the end. So that's your actual yield, which you actually went to lab and recorded and collected. Divided by your theoretical. So your theoretical is like, that's the calculation we do in class to say, okay, how many moles? Okay, based on how many moles I have in the reaction, how much mass do I expect to get? And then we multiply that by 100 to turn it into a percent. So that makes percent yield calculations a little bit consuming because we have to kind of figure out what is our theoretical yield first, and then we can figure out what we actually obtained in lab, and then use those two to find the percent yield. So in this reaction, we're looking at octane burns in the presence of oxygen to produce carbon dioxide and water. And it's not a limiting reagent calculation because they tell us we've got 30.65 grams of octane and it reacts with excess oxygen. So we don't need to worry about the oxygen, it's there in excess. And then when we do this experiment in the lab, so here's our actual yield, we actually recover 81.69 grams. So that's our actual yield that we measured out at the end of the experiment, right? 81.69 grams. We need to use the initial mass of the octane to find our theoretical yield. So with the 30.65 grams of octane, right? We can't go grams to grams because octane has a different molar mass than carbon dioxide. We can, we have to go to moles first. So I look up the molar mass of octane, right? The molar mass of octane is 114.23 grams per 1 mole. So step one, we get out of grams and into moles of octane. So we've got 30.65 divided by 114.23 gives me about 0.2686 moles of octane. From there, I want to convert that to moles of CO2 to say, okay, based on the moles of octane in the reaction, how many moles of CO2 should I make? And we get that ratio from our balanced chemical equation, right? The coefficients tell us for every 2 moles of octane, I'm going to make 16 moles of CO2. So 8 times as much CO2 out of that reaction, right? So moles of octane cancel out, and we multiply by 8 to see that we're going to make about 2.15 moles of CO2 in the reaction. So that was step 2 for us. All right, now we get to step 3. Now that I've got moles of CO2, I can convert that into mass of CO2. So we made about 2.15, we should make 2.15 moles of CO2. I need to find the mass of CO2 to get my theoretical yield from this reaction, right? The molar mass tells us for every 1 mole of CO2, I need 44 grams of CO2, so moles cancel out, we multiply by 44. And we should have made about 94.54 grams of CO2. So that's our theoretical yield. We theoretically should have got 94 grams. When we actually went to lab and did the experiment, we got 81.69 grams. So now we can calculate our percent yield. Right, I actually got 81.69 grams out of this, and I was supposed to get 94.54 grams out of this. So 81.69 divided by 94.54, I multiply that by 100 to get something around the order of 86 86.4% yield for this reaction. All right, again, what makes it kind of time consuming is that we have to go through all the steps to use our initial mass to find our theoretical yield, right? How much carbon dioxide should I make in this reaction? Once we went through all those steps to find how much CO2 we made, then we can find percent yield, because we know when I actually did the experiment, I collected 81.69 grams, even though I was supposed to collect 94.54 grams. Use those two to find that my percent yield in this reaction is about 86.4%. And after going back and taking a look at the numbers given in the problem, we've got 4 significant figures in the 30.65 grams and 4 significant figures in the 81.69 grams, which means we should have 4 significant figures in our percent yield. So I would say 86.41% to make that 4 significant figures. If you have to put that in scientific notation, 8.641 e to the 1. Again, be careful with these problems. The steps will be the same, but your numbers might be different. Your initial mass might be different. Your amount of CO2 made might be different, but the steps to find the percent yield would be the same for this problem.